Welcome. Today we will discuss the anatomy of a language processing system, focusing on the complete journey from source code to final execution. Let us begin by understanding the language processing pipeline, which is a series of stages that a program undergoes before it can be executed. At its core, a language processing system is defined as a collection of programs that translate high-level source code. Its core components include the preprocessor, compiler, assembler, linker, and loader. These elements operate in a sequential workflow, transforming the initial source program into a state ready for memory execution. It is an integrated chain where each component is crucial for achieving the final machine-level program execution. The first step in this chain is the preprocessor's role in code preparation. This phase handles initial transformations and source code modifications before the actual compilation begins. Key tasks include expanding macros, including header files, and removing comments from the code. The output it generates is a modified source program, which is then passed to the next stage. A common directive example is the hash-define directive, used to replace symbolic constants, such as pi, with their actual values. Following the preprocessor, the compiler undertakes the task of translating the high-level code. Its primary function is to convert the preprocessed source file into an assembly language program. This is a multi-stage process that involves lexical, syntax, and semantic analysis phases. These are followed by the final stage of generating intermediate code. Assembly language is often the preferred output, as it is relatively easy to produce and to debug when necessary. Next, the assembler and linker work to bridge the gap towards an executable file. The assembler's function is to translate the assembly language into relocatable machine code. This creates object files with extensions like .obj or .o, which can be loaded into different memory addresses. Subsequently, the linker's purpose is to integrate these multiple object files into a single, unified executable. It performs dependency resolution by connecting calls to external functions and resolves library definitions. The linker also assigns the correct memory addresses to various program segments, producing the absolute machine code as its final output, which is a complete executable program. The final component in the pipeline is the loader. The loader's task is to prepare the program for immediate execution by the central processing unit. This involves loading the absolute machine code directly into main memory, or RAM. The loader also handles resource allocation, ensuring the program has the necessary memory space and other system resources to run. A thorough understanding of this entire pipeline is a fundamental concept and is critical for all software developers. In summary, the language processing system is a complete and intricate pipeline. Mastering its stages is an essential requirement for effective modern software development.